Before we get started, I'm just wondering, does anybody have a definition for a function? Do you know what a function is? Like right now, if I ask you, can you spit something out?
The x's have to be different or something.
Okay. It's not bad. Did I never teach you what a function was, Colin? In Algebra 1? What a terrible teacher you must have had if he never went over a function. Or Taylor.
I know the x can only have one y.
A function is a special relation where every input x can have exactly one output y. Right? That's what a function is. So when you said all the x is different, you kind of were in that same ballpark. You just have never had me give you that definition before, so you wouldn't have known it. Yeah, each input has exactly one output. And then we talk about how can you tell graphically if a relation is a function or not. Does anyone remember looking at a graph? Like, is this a function? This graph right here?
Yes.
Why?
Because they don't overlap.
Okay, so, okay. Is this a function?
Yes. No. Yes.
Okay, so we all agree this one's a function, right? Function.
No,
That's two less for one
twelve has the same x.
Let me put it on a graph here. So if I pick some point, say this is the point 1, 1. Can you guys see the green? No, green's bad. I can't remember. I knew there was one color I have to change. Is that better? Okay, so if that's the point 1, 1, does that same x have another point?
No.
Good morning, teachers.
Okay, so we were talking about this point 1, 1. So its input, its x value is 1. So this x value has a y value. Does this same x value have any other y values that it takes on? No. Let's think of a different point. What about this point? Let's say this is the point -2, 4. Does this x value have any different y values? No. So there's probably a way that you learn to tell if a graph was a function or not very quickly. Does anyone remember?
Does it pass the vertical line?
Vertical line test. That's it. If I can draw vertical lines that only touch the graph once, then it is a function. So some examples of things that are not functions. This would not be a function. If I had something, let's do a harder one. If I had something like this. Okay, so I'm making a piecewise function. Have you guys ever seen a piecewise function? Yes, no, maybe? Okay, we'll do some later. So here, does it pass the vertical line test?
Yes.
And here.
Yes.
And here.
Yes.
It passes the vertical line test everywhere except right there. Right? So that one would not be a function because it has to pass the vertical line test everywhere. Even though there's just one spot, it doesn't pass it. So in order to make this a function, I would need to make one of those endpoints an open circle versus closed. Now it is a function. Okay, so that's about the most extreme value. Anyways, that was just a review. That's not even what we're learning today. Sorry, I got sidetracked. So here we go. Let's keep going. Let's read the thing. Understanding heart rate can be an important tool for your own personal exercise training and for monitoring your cardiovascular health. One measure that is often calculated is your max heart rate, or HR max. Your max heart rate depends on your age. So this phrasing here, using the term depends on, it should lead us into a discussion about independent variables versus dependent variables. So if heart rate depends on age, which one of those variables do you think is the dependent variable? The max heart rate. So HR max would be our dependent variable. And then what would be our independent variable? Age. And I guess I didn't tell you guys, we're in your... So the dependent variable is your maximum heart rate. The independent variable is the age. What about for any generic function? Say I had a function with an x value and a y value. Do you guys know which one we treat as the independent variable and which one we treat as the dependent variable? Okay, that's fine. So our independent variable is normally our x, and our dependent variable is our y. What's another way we could say y that's fancier and more mathematically appropriate? Oh, okay, well that's, okay, all right, okay. The range is the list of all possible y's, which is not exactly what I'm talking about, but that's a good thought. It's a good thought. F of x, function notation, that's the one I was looking for. All right. Almost everything that we do in Precal, we deal with functions. We like functions because functions are consistent, right? Have you ever dated someone that's not consistent, that changes on a whim? There's somebody different every day? That's not fun. That's not a good way to live your life, okay? Have you ever went to a vending machine that you pressed a button and you didn't know what was going to come out of that button? Is that a fun way to live? Maybe, if you like living on the edge, right? Well, like the same thing every day. Consistency. Anyways, don't get sidetracked. Okay, let's go. So, we've got independent versus dependent variables. Okay, good. Let's read one. The table below gives data about the relationship between age and max heart rate, which is measured in beats per minute. So we can see here our age is essentially just our list of X's, right? Our inputs. And the maximum heart rate is our list of Y's, or our F of X. So if you had to describe the relationship between age and max heart rate, how might you do that? Okay. We don't have to be let's don't be so technical. Why so serious? Dumb it down some.
When age goes up, the max heart rate goes down.
Yeah. Or an inverse relationship. But hey, we don't have to say that. Plus, the reason I like Hope's answer a little bit better too is because it gives context to the situation. So legitimately, if you have a question on the AP Precal exam that is looking to make sure you understand the context of the problem, if you just said it's an inverse relationship, even though you're not wrong, you wouldn't get credit for that. Versus this, you're talking about person's age and you're talking about heart rate goes down. You're showing that you understand the context. So we're gonna get a lot of practice talking that way. Good. Questions on A. B, predict. What do you think the max heart rate is at 35 years old?
185.
That's 185.
How did you figure that out?
It's closer to 40, but also it's in the middle of 25 and 40, but closer to 40.
Okay. So because 35 is between 25 and 40, you expected the max heart rate to be 190, between 195 and 180.
Yes.
Okay, I follow that. But how'd you come up with exactly 185? I get, okay, you said it's a little closer to 40. So was it still just a...
Those are 15 years apart and 15 beats per minute apart.
Okay.
So we went up 20 years, so we should go down. Or we went up 10 years, so we should go down 10 years.
And you just need to explain that out. Okay? If that was your method, that's perfect. All right? You just need to write that out, if that's what you did. Anybody do it differently? You see what he's talking about? He figured out the difference between the age here went up 15, and he figured out the difference here went down 15. So we're talking about, what are we talking about here? What are we essentially looking at? This is how much our graph rose. This is how much our graph runs. So we... Yeah, it's a slope. We rose negative 15. We ran 15, which means that's negative 15 over 15, which is negative 1. So you could just say, here's another way you could say it. The max heart rate goes down 1 BPM per year. You don't have to be that detailed either. What Cam said is perfect. Right? As long as you have an explanation, a reason. Questions? 2, the graph also shows the relationship. So here they have taken what was in chart form and they have put it on a graph. So using this graph, what is the max heart rate of a 60-year-old?
160.
Yeah, and how did you figure that out? You're right.
You go to 160 on the graph, and then go right till
That's the way you did it? Did you do it that way?
160.
Did y'all go to 160 first?
No, you go to 60 and then go up.
So I looked for where the age was 60, right? That's the way I would have done it. Look where the age is 60 and then find out the output value, right? This was my input, my independent variable. It's what I chose. I chose 60 and I found out what the output was, the dependent variable. So the max heart rate is 160. And if I want to make that look very official, very mathematical, I could say the function evaluated at 60. So what does that mean? I plugged in 60 for X. 60 was my input. And I found the output was 160. That's the official function notation. Okay, B. What age would you predict someone who has a max heart rate of 200 beats per minute?
Years old.
Okay, This time, I would have done it more like Cam said the first time, right? I would have went to 200, and I find where that's at. And you're correct. It's 20 years old. And so, essentially, the question... Let's talk about the difference between A and B here. For A, I started with a 60-year-old, and I wanted to know what is the output. Right? That's the thing I was looking for. This second one, B part, I started by knowing the output. I started by knowing the Y value. So where the question mark was before, now then that was filled in with 200. And what was I really looking for? I was looking for the X value, right? I knew f of X. I knew Y was 200, right? You follow that? But I didn't know X this time. And I found that X has to be 20 after the fact. C, can you write an equation that could be used to determine the max heart rate of someone who is X years old? Review, what's an equation? Equation? If you had to spell it out for me. I don't know what an equation is. I've never heard that term. Is it a term of endearment? You call your honey an equation? Hope doesn't. That's good. That probably wouldn't work out very well for you. Don't call her obtuse either. That's an old school term that means unreasonable. You're being obtuse. But I guess you could go acute. No, okay. So, nobody knows what an equation is? If you solved an equation?
I know what an equation is. I don't know
Just-
the definition.
Okay, well, I'm not being technical. I liked your definition before, where you said all the X's were different. I'm okay with something. This one's actually I have a very Sand Mountain definition for an equation.
It's how you solve something.
Okay, so we do solve equations a lot. What's an equation look like? Just give me an example of an equation you might solve.
Y equals mx plus b.
Okay, well now then you're showing off with the equation we're looking for. That is an equation. You might think of a different equation. That's a perfect equation. That's what we're fixing to use. But now just make up any other random equation.
2y equals 3c plus 4.
I agree. This is also an equation. What do these equations have in common?
They have an answer.
That's not the way I think about it. Not an answer.
You can solve them.
Now you're just trying to be technical with me. That's not what I'm looking for either. Somebody give me a different equation.
y2 minus y1 divided by x2 minus x1.
That's not an equation. That is a formula. I could turn it into an equation. What's the part of the formula you forgot?
Equal sign.
M equals? So what's an equation? It has an equal sign. Equation. A math statement with an equal sign. Has some variables, some numbers, right? A math statement with an equal sign. Equation. What's a math statement without an equal sign? What about if I didn't have that M equals? What do we call this?
A formula.
It's not in math. They both could technically be formulas, but we don't call that a formula. It also starts with an E. You don't solve these. You solve equations, but you simplify these. Starts with an E. Some people might say surprised is one. So is fearful and shocked. Expressions. Okay? Expressions are math statements without an equal sign. Anyways, Let's don't even talk about inequality. Oh, gosh. What's an inequality? What's the prefix? Yeah, not equal. So how do we do not equals in math? Inequality.
A weird equal sign.
What's a weird equal sign? Does it mean like it's got tattoos and an earring? I don't know what you mean by a weird equal sign.
A little squiggly, and then it's got, sometimes they got like a line. I think so.
That does mean not equal, but that's not an inequality.
Inequality, 5 is less than 6.
Those are inequalities, less than and greater than. But it's not equal, right? One side's bigger than the other. Okay, I'm done. C. Sorry. I'm just trying to get all your math synapses firing. Boom, 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 boom. You know what synapses are? I don't really know what they are either. It's just like the connections in your brain that fired neurons. I took physics, okay? I didn't take anatomy. C. Write an equation that can be used to determine the max heart rate of someone who is X years old. Well, right here, we've got a table to figure out the max heart rate of someone who is X years old. We have a graph to find the max heart rate of someone who is X years old. Now let's write it as an equation. So how could I take this and write it like this?
So Y is going to be max heart rate.
Y is the max heart rate. You want to write that out instead of writing Y?
No, I'm
But yes, you're correct. Because the Y value is our Y-axis, right? Max heart rate is the Y. So what's needed to put something in Y equals mx plus b form? M? What's the M represent?
Slope.
The slope. Do we know the slope?
Yes.
Oh, negative. Okay. All right. And then what else do you need to know to put something in this form? The B, which is the y-intercept. How can I find the y-intercept from a graph? It's not always the top. It is the top this time. When x is 0, where it crosses the y-axis. And you're correct. In this case, it is the top. But I don't want you to think it's always the top, because if the graph goes this way, right, it wouldn't be the top. It would be the bottom. It's not always the bottom. Let's talk about that. Okay. I guess if it's a line, it's got to be top, bottom, or it's got to be horizontal. Okay, so f of x equals negative 1x plus 220. Yeah. Anybody come with something different? You could have written it as 220 minus x. It's the same thing. That's what you did? That's fine. That works the same. It's just not in our official slope-intercept form, but it's an equation. That works. It didn't say it had to be slope-intercept form. D. What do you think are reasonable values for x in your equation? So what did x represent? Age. So what are some reasonable ages to plug in?
1 through 100. 0 to 100.
Okay, I would rather start with 0 than 1. I'm good with that. Let's say 0 to 100. Why? Why did we pick this?
Because people really don't exceed the age of 100.
Okay, so people rarely exceed 100 years of age. Okay, is there any other reason?
You can't be negative years old.
That's the other side of it. You did a good job explaining the 100 part, but where did we get 0 from? Well, we had to start somewhere. But you can't be negative years old. Except technically, when you're pregnant, you have the kid has a heartbeat in the womb, and is that negative years old? Because they're not.
I guess what it is.
My brain can't comprehend. And can't have a negative. I agree.
Is that that's part of zero? No, it's not part of zero. It's an outlier. Because maybe the baby's heart rate is at 200, over 200. 20.
Outlier. I'm trying to think. I'm trying to get with you. I'm trying to get on your level. I'm trying to figure out what you're saying.
It just doesn't apply.
What doesn't?
The baby.
Yeah, you're right. It just doesn't. I was just being dumb. We should start at 0. I completely agree. Now, let's turn this into, let's make it look very mathy and very official for D. We could say that the x value must be greater than or equal to 0, but it must also be less than or equal to 100. This is called a compound inequality. Right? And I'm telling you, the x is between 0 and 100. Do you guys feel comfortable writing compound inequalities?
Yes.
Do you? Okay. Most time people don't like writing it this way. Just notice your inequality signs should always be pointing in that direction. Now, they don't always have an equal to sign, but anytime you do something like this, it should always be a number is less than x is less than a number. Right? And it used to confuse me, so I think about it exactly the way I showed you guys there. I started to say x must be bigger than my lowest. So I always start with the x and go this direction. And then I go x to here, because it used to. But you guys must be smarter than I was when I was a wee lad. We could also write this in interval notation. Have you guys seen interval notation? Probably not. Let's see. How? There's a way out there. It is. There's a way I can make my eraser bigger. So interval notation would look like this. If the lowest value that x can take on is 0, we would put a bracket and put 0, comma, the highest value is 100. Close it.
We did this last year.
You probably had done it. You just probably didn't know the vocab for it. Interval notation. So this is something that you will have to do on your Canvas assignments. Okay? Identify domain and interval notation. That's a big deal. So just making sure you've seen that before. And then we know when to use a brace versus parenthesis, right? We're good with that. Okay. Do you know about unions in domains?
Yes.
Do you, like, so if I graphed I'll come back to that. Let's finish this. E, do you think it's possible to have a max heart rate of 100 beats per minute?
No. Maybe. You'd have to be 120 years old. So, has anyone in a while achieved that feat?
I don't know about quite 120, right? I know there's been people in the high 100 knots, like 108, 109. There may have been some low teens. I don't know of any recently that were there. So my answer here would be, I would say possible, yes, but highly unlikely. And then what's my explanation? Why? Person, you guys said why. Person would have to be 120 years old. The people at A+, they said, no, it's not possible. But I disagree. I wouldn't want to say it's not possible. But we both would be correct because of our explanation. Like, as long as you explained why you thought what you thought and it was reasonable, you're fine. Okay?
If you said yes, that's crazy.
Yeah, if you said, yeah, I mean, if you just said, yeah, it's definitely doable, then you might could be wrong if you were very flippant with your... So here, let's talk about what's our range for what we decided the max heart rate was. So if our domain is 0 to 100, what would our range be?
220 to 120.
That's it. The Y's would be between 220 and 120. Can you guys see this number? I did a bad job. This is 220 is less than or equal to f of x is less than or equal to 120. And again, in interval notation, 220 to 120. This would be my range. Range is the list of all possible y values. This one would be our domain, right? List of all possible x values. You guys know the difference between those, domain and range, x and y's. Okay, last one. While the formula found above is easy to use, researchers found it to be less accurate for women. They proposed a function, h of x equals 206 minus 0.88x, to estimate the max heart rate, h of x, for a woman that is x years old. Okay, so I don't want to do the second part yet. Let's look at the equation that they have presented. Tell me the differences between the equation we found, which I guess is going to be for men, 220 minus x, versus the equation for women, which is 206 minus 0.88x. Can you guys interpret the situation from just equations?
Their heart is going to be lower.
It's way too broad and vague of a statement. It's not necessary. It's not necessarily lower. Go ahead, Cam.
Would that range be backwards?
Yeah, I did it backwards. Just ignore me. I'm a moron.
Well, it
Yeah,
starts,
fix that. Thank you for that, Cam.
well, it starts at a lower, or at the age of 0, where, well, it starts lower than a male's. It also has a less decrease, because it only goes down 0.88 instead of 1.
Okay, so when they're born, I agree. When they're born, a woman heart rate would be lower. 220 versus 206, right, is the initial. But on the flip side, the males lose 1 beat per minute for their life, while the females only lose, or not minute, they lose 1 beat per minute every year, the males do, while females only lose 0.88 beats per minute every year. So there could be a point, like if we think about these graphically, let's say the male graph is here, right? That's my 220 minus x. The female starts at 206, which is here, but because the slope is negative 0.88, it's going to not be tilted as much, right? It's going to be a little flatter. And so there could exist a point in time where it switches, where the woman's heart rate is actually higher than the man's. You follow why I said you can't just generally say it's lower. It was lower to start with, but because of the situation, there exists a point somewhere. I don't know what age this is. It may be 180. It may be so far out that it's not really plausible. But I don't know that until I solve it out and find it. I'm trying to do it in my head right now. It's gonna be in the hundreds, I think. So I think it is gonna end up being outside of our range, our domain that we picked. So anyways, how could we find h of 32? So let's find a woman's, What is h of 32 even saying to start with? If it asked me to find h of 32, give me context. What am I finding? I about said it. That's why I stopped myself. So we are finding when the age is 32. I agree with that. Give me more detail. We gotta start building that detail muscle. You're right, the age is 32, but give me a full sentence. Give me a full thought.
We need to find out the max heart rate at the age of 32.
Finding, and you missed one word in there that I would want to see. What is this max heart rate? Whose max heart rate is it? Woman, female. That's the only word that you missed. Everything else is perfect. Find a woman's max heart rate at the age of 32. Because we're finding, when it asks me for age of 32, we're finding the Y value, right? We know the X. We know the age. So we are finding a woman's max heart rate at age 32. And how could we find that? Well, we don't have to make the equation. The equation's already made, right?
Plug 32 in for X.
Plug 32 in for X. That's it. So H of 32 would be 206 minus 0.88 times 32. So it'd be 8, 16, 24, 24, and 1.6 is 25.6, and that would be 180.4. Somebody double checking me? You guys haven't plugged that in? I mean, I'm rusty. I've had all summer off. I don't know if I did that correctly. I said 180.4. That's what I'm going with. What is it?
I got 170.
What, you did 200 instead of 6?
I got 177.
177.84. Do we have a second? Okay. I told you I was going to be rusty. It's going to give me a minute. 8, 16, 24. Yep. I know. Yep. I didn't do the 0.8 times 30. I did 8 times 30 to get 24. Don't worry. I'm doing mental math. Just ignore me. Y'all don't have to know that. Okay, so